In recent years, the security environment of the Middle East has entered a period of heightened uncertainty. Long-standing rivalries, unresolved territorial disputes, and shifting regional alliances have created a complex strategic landscape where advanced military technology plays an increasingly central role. Among the most closely watched developments is the evolving missile capability of Iran and the defensive architecture built by Israel to counter potential threats. The possibility of large-scale missile exchanges has become a key concern for defense analysts, policymakers, and security experts across the world. Major Israeli urban centers such as Tel Aviv, Haifa, and Bat Yam represent not only population hubs but also economic and technological centers that are critical to the country's national infrastructure. For this reason, discussions about missile defense systems, interception rates, and strategic deterrence often focus on how effectively modern defensive networks can protect densely populated areas from increasingly sophisticated ballistic threats. Missile defense has long been one of the defining elements of Israel's national security strategy. Systems such as Iron Dome were designed to intercept short-range rockets and artillery threats, while more advanced layers such as Arrow and David Sling were developed to counter longer-range ballistic missiles. Together, these systems form a multi-layered defense architecture intended to detect, track, and intercept incoming projectiles before they reach populated areas. In many previous confrontations, interception rates reported by Israeli defense authorities have been extremely high, often above 90% against certain categories of rockets. However, military analysts frequently emphasize that no missile defense system can provide perfect protection, especially when confronted with very large numbers of incoming threats arriving simultaneously from multiple directions. One of the strategic challenges often discussed in defense literature is the concept of saturation. In simple terms, saturation occurs when the number of incoming projectiles exceeds the interception capacity of defensive systems within a short period of time. In such a scenario, even a highly advanced defense network can become strained. According to various open-source assessments and security reports, Iran has spent decades developing an extensive missile program that includes both liquid fuel and solid fuel ballistic missiles with ranges capable of reaching targets across the Middle East. Some estimates suggest that Iran possesses a stockpile of several thousand missiles produced domestically through its defense industry. The scale of such inventories has led analysts to examine how sustained missile launches might challenge even highly developed air defense networks. Recent discussions in strategic circles have also focused on the technological evolution of certain Iranian missile systems. Missiles often cited in open-source analysis include systems such as the Sejal, a solid-fuel ballistic missile with a reported range of approximately 2,500 kilometers, and the Khaibar-Shikan, which has been described as part of Iran's newer generation of medium-range missiles. Solid fuel propulsion allows missiles to be prepared and launched more quickly than older liquid fuel designs, potentially reducing warning time for defensive systems. In addition, some reports mention the development of maneuverable re-entry vehicles designed to alter trajectory during the final phase of flight, complicating interception calculations for defensive interceptors. Another topic frequently mentioned in defense discussions is the emergence of extremely high-speed missile technologies. Iranian officials have announced systems such as the Fateh series, which they describe as capable of hypersonic speeds. Hypersonic weapons are generally defined as traveling at speeds greater than Mach 5. Though precise capabilities are often difficult to independently verify. Claims surrounding variants like the Fateh 2 suggest speeds potentially reaching Mach 14, which, if accurate, would significantly reduce reaction time for defensive networks. For missile defense operators, reaction time is a critical factor because radar systems must first detect the launch, track the trajectory, calculate interception points, and launch interceptor missiles within a narrow window of seconds or minutes. Speed is only one factor in missile defense calculations. Trajectory, maneuverability, and flight profile can also influence interception probability. Traditional ballistic missiles follow predictable arcs through the atmosphere, allowing defense systems to estimate where an interceptor should meet the incoming target. However, if a missile can change course during its flight, even slightly, the calculations become more complicated. Some Iranian missile models, such as those described in open-source reports about maneuverable variants of the Ahmad or Fatah families, are believed to incorporate guidance systems designed to adjust trajectory during re-entry. While the exact operational effectiveness of such systems remains debated among experts, the concept illustrates how missile design continues to evolve in response to advances in missile defense technology. Another factor shaping this strategic dynamic is payload capacity. Some Iranian ballistic missiles are reported to carry warheads weighing close to 1,000 kilograms. Warheads of this size can produce significant destructive effects depending on their type and target. Military analysts often emphasize that the impact of even a small number of successful strikes in densely populated urban areas could be severe, particularly if critical infrastructure is affected. For cities that serve as economic centers, disruptions to transportation networks, communication systems, or energy infrastructure could have consequences extending far beyond immediate physical damage. Defense specialists also pay attention to electronic warfare aspects that may accompany missile operations. In modern conflicts, electronic interference or radar disruption, often described as jamming or spoofing, can sometimes complicate the performance of air defense systems. If radar signals are temporarily degraded or confused by electronic interference, defensive systems may have less time to accurately track incoming threats. While details about such capabilities are rarely confirmed publicly, analysts often examine the potential for electronic warfare tools to play a supporting role alongside missile launches. Another dimension frequently highlighted in strategic analysis involves economic asymmetry. Missile defense systems require advanced sensors, interceptor missiles, command networks, and continuous maintenance, making them extremely expensive to operate. Some estimates place the cost of a single long-range interceptor missile at several million US. In contrast, the cost of producing certain ballistic missiles may be significantly lower, particularly when a country maintains a domestic manufacturing base and produces missiles in large quantities. This imbalance creates a strategic question often discussed in defense policy circles: can sustained missile attacks impose economic pressure on defensive systems even when interception rates remain high? These technological and economic considerations are part of a broader strategic competition that extends beyond a single confrontation. For Israel, maintaining credible missile defense capabilities is considered essential to protecting population centers and preserving national resilience. For Iran, missile forces have long been viewed as a key element of deterrence, particularly in the absence of a modern air force comparable to those of some regional adversaries. As a result, missile technology has become a central pillar of Iran's defense doctrine. The implications of this evolving missile dynamic extend far beyond the immediate region. The Middle East contains some of the world's most important maritime trade routes and energy transit corridors. Any escalation involving large-scale missile exchanges could affect shipping lanes, energy markets, and global economic stability. International observers therefore monitor these developments closely, not only because of their regional significance but also because of their potential global ripple effects. For defense planners around the world, the situation raises important analytical questions. How effective can missile defense systems remain if confronted with larger and more technologically advanced arsenals? Could future conflicts involve a combination of ballistic missiles, drones, and cruise missiles launched simultaneously from multiple directions? And how might countries adapt their defense strategies in response to the continuing evolution of missile technology? In many ways, the interaction between offensive missile capabilities and defensive interception systems reflects a broader technological cycle. As missile defenses improve, offensive systems evolve to overcome them. In response, defensive networks are upgraded again, creating an ongoing competition between detection, interception, and evasion technologies. This cycle is not unique to the Middle East, it is visible in defense planning across many regions of the world. Understanding these dynamics requires careful analysis rather than simplified narratives. Missile systems, interception technologies, and strategic doctrines are complex topics shaped by engineering constraints, geopolitical considerations, and economic realities. Public discussions about these issues often rely on incomplete information, since governments rarely release full details about their military capabilities. As a result, analysts rely heavily on open-source intelligence, satellite imagery, academic studies, and defense industry reporting to build a broader picture. In the end, the evolving missile landscape of the Middle East illustrates how rapidly modern military technology can reshape regional security calculations. Developments in missile speed, maneuverability, electronic warfare, and production capacity all influence how nations evaluate both risks and defenses. At the same time, the human and economic consequences of armed conflict remain significant, particularly when densely populated urban areas could be affected. For viewers seeking to understand global security trends, examining these technological and strategic dynamics offers valuable perspective. The relationship between missile capabilities and missile defense is likely to remain a central issue in international security debates for years to come. Observers will continue to watch how regional actors adapt their strategies, how defense systems evolve, and how the broader international community responds to the risks associated with advanced missile technologies. As a final reminder, this video is intended solely for educational discussion and analytical understanding. It does not endorse military operations or conflict in any form. The information presented is drawn from publicly available sources and strategic analysis, and it is meant to encourage informed, critical thinking about one of the most complex security challenges facing the modern world.